Okay, so we're going to start the second half of this lesson by looking at how we come up with the derivatives of the exponential and logarithmic functions that we've looked at in the last two sections. So these are kind of like how we derive the formulas to differentiate these functions. So if we start with the function y is equal to e raised to the f of x power, if we want to actually derive the derivative of this, we're going to take the natural log of both sides of our equation. And then when we do that, the right-hand side is going to wind up simplifying to f of x. And then we can use implicit differentiation to take the derivative of that. So when we do so on the left-hand side, we get 1 over y times y prime. On the right-hand side, that gives us f prime of x. And then we can isolate y prime by multiplying both sides by y. Now, if we were doing implicit differentiation with this function to begin with, it would be okay to leave our derivative in terms of x and y. However, the function that we are starting with initially is this, where we have y written explicitly in terms of x. So when we differentiate this, the derivative had better be written explicitly in terms of x as well. So we're going to replace y with e raised to the f of x power, okay, times f prime of x, and that was the derivative of that exponential function. Now we can use the same approach to take the derivative of y is equal to a raised to the f of x power as well, by taking the natural log of both sides. We can then pull the exponent f of x out front as a factor. And then again, we're going to use implicit differentiation to take the derivative of both sides. Okay, so when we do this, again, the derivative of the left-hand side is 1 over y prime. This factor here, the natural log of a, is a number. It's a coefficient, so we can pull it out front of the function. So that's going to be the natural log of a, and then the derivative of f of x is f prime of x. Okay, so again, we're going to isolate y prime, multiplying both sides by y. And then once again for this one, because we have y written explicitly in terms of x to start, we're going to go ahead and replace y in the derivative with a raised to the f of x power. So we get a raised to the f of x power times the natural log of a times f prime of x. Okay, so in the next videos, we'll take a look at how we take the derivatives of log functions. And by the way, this process here is what is called logarithmic differentiation. And we're going to do some more examples of logarithmic differentiation as we work through this lesson. Okay, on to the next video.